All right, so I'm literally going to go through the same information that you guys went through. So you should probably have a picture. And the first question you guys asked me was, did the truck start at the same place? It's the fact that their distance between them is changing. You're going to have to assume that they are starting in the same place. So one truck is going east. One truck is going north. Truck A, truck B. So you should be able to figure out you have a triangle. The triangle, if I drew three of them, would keep getting bigger. Okay? So literally, triangle number one, they start together, then the distance keeps getting bigger and bigger. All right? It it does not matter which one is B and A, but I'm using the truck name. That's fine. So truck A, truck B, so I'm just going to use A, B. I'm going to call this one C. My third picture is usually my instant picture. The only reason I draw these three is to check are they constant. So did anything constantly stay the same? No. Okay, all three sides were changing. So let's go through the information. First, I did get this question in fourth period, which was, let's see, constant. Are these constants? That's the question I got in fourth period. No rates will ever be considered constant. Your constants come from your picture, and your constants are distances or lengths that don't change. Those are constants. So yesterday we did the ladder problem. The ladder was constant. Nothing here. We just answered that a second ago. No sides are constant. So there's none here. All right. So your given information were those two, which were truck A. That's a rate because it says miles per hour. So I want to do 40 miles per hour. The other given was oh, that's supposed to be an A, dB, dt, and that was 30 miles per hour. So my givens, my constants, there were none. Next information I was supposed to do is my instant. I want to answer the question instantly when the time was 6 minutes. I'm going to even put that in my picture. All right. My question, which I'll squeeze up here, says how fast is the distance between the two trucks here and here changing? So how fast means I must be doing some kind of ddt. Which variable? In my picture would be your C. So that's my question. So I'm using a formula that uses A, B, C in a right triangle. That should be pretty easy for you. So what's my formula? A squared plus B squared equals C squared. Okay? Do we have any constants to put in prior to the derivative? No constants, so I'm going to have nothing put into the formula. Now I'm just going to take its derivative. 2a dA dt plus 2b dB dt equals 2c dC dt. If you want to, you can divide everything by 2. They cancel. But what I want to look at is, if this is my question, what do I need to know to answer that question? I need to know A, I need to know dA dt, I need to know B, I need to know dB dt, and I need to know C. Now, look at the information we were given. I know these two things, the dA and dB. I don't know A, B, or C at the instant of 6 minutes. So that means you need to go find more information at that instant of 6 minutes. But there is an issue. How were the speeds of the truck given? Miles per hour. So if they want minutes, we can switch over to minutes. Okay? You have an option. You can switch this into an hour, or you can switch this into these into minutes. Pick what would you like me to do? Problem in minutes or problem in hours? First one I hear. I heard minutes. So it actually doesn't matter which one you choose. In the end, your answer ends up being the same. Okay? So, miles per hour, how do I change my hours over? 1 hour is the same as 60 minutes. So my hours cancel. Same thing here. 1 hour is the same as 60 minutes. That's how you change your units. You won't have to do that often at all. I use this problem just to show if the units don't match up, you're going to have to change them. All right, so this dAdt turns into, I believe, 2/3 miles per minute. How you really read that? 2 miles every 3 minutes. This one turns into 1/2 miles per minute. 1 mile every 2 minutes. So now, if I want 6 minutes later, if I'm driving 2 miles every 3 minutes, how far did I go in 6 minutes? Ooh, be careful. I went 2 miles in 3 minutes. How far did I go in 6 minutes? I did 4 miles in my 6 minutes. Letter B, I went 1 mile every 2 minutes. Therefore, I went 3 miles in 6 minutes. Therefore, if this is 3, this is 3, this is distance of 4, then this distance is 5. Different from rates. Please do not just use the rates to solve the problem. If you don't use calculus, it means you did something wrong. Okay? All right, so we got, these are all in miles. We can now put everything in. So let me actually move this over. Actually, let's just take the whole formula. What's wrong? Anthony's pregnant? That's interesting. I didn't even know. Yeah, they smell things oddly. Anthony Ramos is pregnant. That is now on YouTube and on every video. All right, your A distance was this one, so I think that was 4. Was that right? Your dAdt was the first one, so that was 2/3. Plus 2 times your B was 3. Your dB/dt was 1/2 equals 2 times C, which was 5, and then dC/dt was my question. I'm going to provide all the 2's. So I end up with 8/3 plus 3/2 equals 5 dC/dt. So you're just going to solve for dC/dt. So here we get 16. I'm going to actually go this way. So multiply that by 3/3. No, just kidding. 2/2. This by 3/3. So we get 16 plus 9. Is that 25/6? All right. And then I'm going to divide by 5. So I actually get 5/6. What units were we in? So distance was in miles. Time was in minutes. So what if I want to know by hours? Go backwards and change 60 minutes for every 1 hour. So my actual answer would be 50 miles per hour. Yes, it did end up being a 30, 40, 50 triangle. Do not, that's why I like doing this. If you said, oh, it's Pythagorean theorem, 30, 40, 50, answer's 50, you would get no credit. That's why I show this. The answer's 50. You might have known that, but you have to show the answer. Angelica? Where did the 5 come from? The 5 was the C distance. Remember going backwards? Remember the triangle? 3, 4, 5? Okay. Laura? Yeah. Those are C's. Oh, that's an ugly C. There we go. All right. Are we good? Alex? Oh, that was a question Laura gave. There was no R. I usually do my hypotenuse to be R, and I think that was what was in my head. All right. The answer is that the distance between the two trucks are moving by 50 miles per hour at the instant of time equal to 6. Okay? All right. So now I'm going to actually show you I think, this one. This problem. So find that one in your packet. And then while you guys are doing that, I'm going to look real quick. So you actually have a plane flying across. All right. So the plane is flying. Wow. All right. So the plane flies west at 700 feet per second. The searchlight under its path tracks it. How fast is the light pivoting when the plane is 1,000 feet east? So we're only going to answer the first question, this one. Okay? So 1,000 feet east. It's raining, it's raining, it's raining. Ah. Okay. So, is that what's on yours? The rain? Ah, now it's not raining anymore. Okay, so the question's at the bottom. The question we are going to answer is, how fast is the light pivoting? Okay, so that's a DT. Whose DT is it? D. Whose DT is it if I'm trying to do D theta? The light pivots based on an angle. Therefore, d theta dt is what we're actually being asked. If it said, how far is the distance from here changing, then that would be a distance. They're asking you the light pivoting, and a little hint, there's a theta in there, okay? So this is the actual question. So I'm going to go over to here, and I want you to do the same exact thing. I'm going to draw my 3 pictures. You don't need to, but I want the given. I want your constant. I want your instant. Your question. And then over to the right, we'll put in my formula. Yep, perfect. I want that information. So while you guys are doing that, I'm going to draw my pictures. My instant. No. That C means constant. It's the same number each time, so it must be the constant. That's all that is. That's why there's parentheses around it. The letters I'm going to use are X, Y, and R. Those tend to be the letters I use for triangles. Yep. It's going this way. And then, yes, perfect. Use Z if you like. All right, given information, I have a plane flying west. Is X getting bigger or smaller? The distance is getting smaller, so my dx dt has to be negative 700 feet per second. That's my, oh, wow, that doesn't say given right there. I thought it did. My bad. Take that back. All right, so dx dt is equal to negative 700 feet per second. All right, constant, when you drew your 3 pictures, you should realize that 4,000 is a constant, and that's my y variable. I want to know how fast the light pivots exactly when the plane is 1,000 feet east, so that's my x value, is exactly 1,000 feet. The question that it's asking me, remember we decided in the beginning, was d theta dt. All right, so there's everything I need. So there must be some formula that relates this angle to the information that's given. So it's a right triangle, and I'm talking about angles. If there were no angles involved, Pythagorean theorem. But now that there's angles involved, Laura, I heard you say it, SOHCAHTOA. Make sure you don't make that mistake. No angles, you're talking about 3 sides of a right triangle, Pythagorean. You have a right triangle and you want to talk about an angle, SOHCAHTOA. So SOHCAHTOA says this one's the opposite. This one is the adjacent. So which trig formula would that be from SOHCAHTOA? So this one's the opposite, and this one is the adjacent, so I must be using tangent. Opposite over adjacent. All right, so given that I have this, I now am going to check, are there any constants to put in, because I haven't done a derivative yet. So the constant that I can put in, I believe, is my y value. So I have x over 4,000. I would not give you a calculator for this problem. So what that means is I'm going to write the step, I'm going to erase it, so don't write this down. If I asked you to take the derivative with respect to t right now, it would look like this. Secant squared theta d theta dt equals 1/4000 dx dt. The question was d theta dt. Look at what you have to know. You have to know the angle, and you have to know dx dt. Do we know dx dt? Yes. Do we know the angle? At the instant. So here's my instant picture. If this side, opposite side is 1,000, the adjacent side is 4,000, I would be answering the question of tangent of theta equals opposite over adjacent. Is that in the unit circle? 1/4. No. That means you have to use a calculator to find the angle. So if I don't give you a calculator, you can't do this. This should be ringing a bell from the intro that we did. I can't do that. So what are we going to do instead? We're going to get the theta by itself. So I'm going to take the tangent inverse of both sides, which causes this to happen. Okay? You'll see in a second why that becomes helpful. Next step, now I already put in my constant. I'm ready to take the derivative. Here it is. The left side's derivative is just d theta dt. Do you notice that you don't have a theta anymore? But if when I had tangent of theta, you got the theta back. The inside has to stay the same of a chain rule. That's why it stays. But now it's not a chain rule anymore. That's why we just have the d theta dt. Equals, tangent inverse is 1/1 plus u squared. That's x over 4,000 squared times the derivative of the inside. Well, here's my inside. It's just 1/4,000 times the derivative of x. Derivative of x would be 1, but multiplied by dx dt. Did I lose anyone in that? Okay, so just one more time, making sure. Derivative of the outside is 1/1 plus u squared. Here's my inside. Leave the inside alone. This whole thing is the derivative of the inside, which is this. Looks weird to most of you, but that's the same thing as 1/140, 4,000 times x. Constant multiplied by x. So leave the constant, and then multiply by the derivative of x, which is the dx dt. Now let's see if I have enough information to solve for d theta dt, which is our question. Do I know the x at the instant? At the instant? Yes. Do I know dx dt? Yes, so I have everything I need to answer the question. So that means there's no more unknowns. You'll be able to solve that question. So let me actually heal that. The next page. I can make it rain again. All right, so what do we get? d theta dt is equal to 1/1 plus, I think it's 1,000 over 4,000 squared times 1/4,000 times negative 700. So I get 1/1 plus 1/4 squared times negative 7,000 over 4,000, 700, sorry, over 4,000. Whew, all right, so that's 1/16, I believe. So 17/16 times negative 7 over 40. And then reciprocal that, and then we'll be done. Whoa. All right, 17 over 16 times negative 7 over 40. And I don't think anything simplifies anymore. That would be the d theta dt. Most people ask the question of how did it get measured? Your thetas are always in radians. Even if the unit never shows up, thetas are in radians. And then the time was in hours, I believe. The speed of the plane was given in hours, seconds, minutes, seconds, 700 feet per second. So then, seconds. Multiply them out. All right. So that will be up today on video. Your homework, one more time, is to finish number 16, your exam review packet, and those of you up here, I made a pile. You get to do the reassessment if you did your test corrections today, okay? All right.